When I was in high school, I lived in Israel, I grew up there, and the Weizmann Institute had a science summer camp, and I got into that in their computer science group. And so that's where I first learned how to program. So I asked to get into that without knowing what programming was, right, or how people use computers. So I'd never done that before. But there I learned Fortran, and I learned all kinds of things. They taught some math, set theory, and it was exciting. You could get these machines to do all kinds of complicated calculations for you, things that would take you a long time to do on your own. So that was fun. When the time came to go to college, I picked a math department. Actually, my father was trying to pressure me to go into physics. And so I went to a university where students in both math and physics shared the first 2 years. So that would give me 2 years to figure out what I wanted to do really. And I continued in math, and I got a bachelor's degree in math, and I came to Berkeley to do a PhD in math. However, I discovered two things. One, math was really hard. And the second was that there were lots of people who were very, very good at it. And, I guess I was good enough to get in, but I didn't feel that I measured up to those. And I saw people who I thought were much better than me having trouble finding a good job, right, at a good university. And at the time, Berkeley started a computer science program. Well, got a lot of extra funding. They had a computer science program before, but they got a lot of extra funding from the US government to increase computer science research. And so there was a huge exodus from the math department, PhD students from the math department to computer science, and I was one of them, and I don't regret that. It's fun. I did computing before as well, as I mentioned, at the summer camp, so I knew what it was like, and I never looked back. I graduated from there and came to USC to the computer science department, and then a few years later moved to ISI again to continue doing computing. So when I was graduating from Berkeley, it was a period where there was a lot of interest in AI. Universities were really clamoring for every graduate, trying to hire them. So I had a few offers. I had an offer actually from the USC Computer Science Department and from ISI separately. I decided to go to the Computer Science Department at the time. I figured, the Computer Science Department was a traditional academic path, right? You become a faculty member, you get tenure at some point if you're good enough, right? And you just stay there. And ISI was different. It had more of this is still true today, right? System building orientation, large projects, collaborations with many people. And I figured I could always make the switch from the computer science department to ISI if I chose to do that later, whereas going from ISI, the computer science department might be harder. So I went to computer science. However, because I knew the people at ISI and was already working with them, I spent my summers working there, and also sometimes during the school year. They had the need of someone to lead some effort. The person who got the funding for it had left ISI, and they didn't want to lose it. And they had someone in the computer science department who they thought could do it. And so I moved over to ISI, at first temporarily for a couple of years. But when that time was up, I realized that I liked ISI more. There was a large group of people doing AI in the computer science department. At the time, there weren't that many. And furthermore, at ISI, they were working in areas that were very closely related to mine. So I thought it would be more fun, better for my career. And so I decided to stay at ISI. I was actually originally interviewed by Keith Unkefer, who's one of the 4 original people who started ISI. I didn't interact with him much. He moved to campus after he interviewed me, but before I actually came to work there on a regular basis. So I didn't see him that much. Danny Cohen, I saw a fair amount. I mean, he worked at ISI for many years, and we did overlap. Our research interests were different, but as a person, I saw him there. He also, he was born in Israel, I believe, so we also shared, some history together. Of the other founders, Bob Balzer was there. He's an early person too. We overlapped for quite a while at ISI. Again, in a somewhat different area. Actually, his was close to AI, but as the way the organizational structure was at ISI, he was in a different group. The other people, someone like Bob Balzer, he had a large influence, a huge influence on what ISI became, and in the fields that he worked in. He had a strong personality, and there were conflicts within ISI. Just within any organization, when you have people who are very opinionated, and but there's no question about the fact that, first of all, he was there for many years, but his impact, the people that he brought in fact, one of the senior people here at ICT, Bill Swartout, worked with Balzer for many years over there at ISI too. So he has a legacy that continues. ISI is dependent on government funding. Pretty much all our work is funded by the U.S. government. And so funding trends affect, what kind of work can be done, how many people can be hired, and so forth. That's more so than in a regular academic department, where, to be fair, computer scientists are expected to get funding for their work. But, there's a lot that covers the university covers a lot of the time of people for teaching, for advising, things like that. So a much smaller portion of their time is covered by external funding. And of course, they want funding to get students as well. But the pressure is not as great as it is in a place like ISI. And therefore, the impact of a government decision to reduce funding for AI is felt much more acutely at ISI. And yes, the AI winter came sometime after I joined, but not to brag too much, but ISI is a good place and has lots of good people. And even if funding overall is reduced, I think ISI has done pretty well over the years in maintaining its programs. Of course, there have been ups and downs. Actually, right now, in case anyone is counting, of course, AI is really in vogue now. One of the things that impacted the growth of interest in AI the most is self-driving cars. I mean, suddenly there's proof that's visible to your average citizen that AI can actually do useful things on, if not the level of a human, but close enough for most purposes. And so there is, again, a great increase in interest and funding for AI. AI now, AI work at ISI hovers around half of what the Institute does. It used to be, 30% or even less. It's one of the first areas that ISI was involved in. AI, the first area was computer networking. Then came AI shortly after, and it's remained a major part of ISI ever since. And now, as I said, it's about half of what the Institute does. Most of the funding at ISI is raised by the researchers themselves. So I should say, even if we talk about conflicts at ISI are tiny compared to regular academic departments, because at ISI, researchers pretty much raise their own funds. They write proposals, mostly to U.S. government research funding agencies. They get the money, they do the work. If they get a lot of money, they can hire people, right? It doesn't take away from anything that someone else has. I can rejoice in my colleagues' success because I lost nothing and they do well. Why not? In regular academic departments, the resources often come from the university or from the university through the department. So if another person is hired in an area that isn't mine, I lose because there won't be money to hire someone in my area. Deans will always tell you that's not true. We'll hire good people regardless of what area they're in. But in fact, that's not quite true. I mean, departments come up with policies on which areas they want to go into. There is a limited amount of money that's available. And so there's naturally a conflict between people who are in the same department or reasons for conflict. That doesn't exist at ISI. So ISI overall, I found, is a much more cordial place. I think everyone there will recognize that, and I think people in regular academic departments know what I'm talking about. So the conflicts always exist. There are different personalities. Still someone thinks, institute funding should go one way or another, or institute policy should be this way or that. But these conflicts are minor, I think, compared to what happens in regular departments. Overall, I'm happy I went to ISI, and it has been a friendly and fun place through the years. ISI is what's called a soft money institute, which means the money that we use to pay salaries and to do our work is raised by writing proposals primarily to government organizations like NSF or DOD. And they, if they like the work that we propose to do, they will give us chunks of money, and we use that to pay our staff. So naturally, there are ups and downs. So we mentioned earlier something like the AI winter, which could be, a trend throughout the funding agencies to not favor a certain area. But there are also challenges due to the fact that, there are a lot of people who are competing with you to get funding. People write proposals. There are lots of good researchers around the country or the world. I mean, ISI has very good people, but there are other good people too. And so there can be periods where you will not succeed. And you won't get funding, and then you have to worry about what to do. Does that mean laying off some members of your project? Does that mean that you yourself have to start looking for a different job? Things like that have happened to me. And in fact, the way I got into the work that I'm doing now, I think I mentioned that earlier, was because of something like this. So I had this project that I originally came to ISI to work on. It seemed to be going very well. I wrote a proposal for a lot of additional funding for this direction of work. I thought the proposal was good. It went to someone at DARPA, the deputy director at the time, who decided DARPA doesn't want to fund this kind of work anymore. So not me personally, not that they found anything wrong with my proposal, maybe they did, but that wasn't the issue. The issue was they no longer wanted to fund this area. And so that was it. And I didn't mention this before, but this was like 2 months after I resigned my USC position, my computer science department position, and took on a full-time position at ISI because I assumed everything was going well and will continue. And then suddenly I'm told, no, your project is gone, right? And that was certainly not easy. There was other work. There was someone who had left ISI and their project needed someone to run it. And I was told, well, would you like to do this? And I could have said no and then not had a job. But, it was AI-ish, and I'll try it. I'll try and do it my way, and let's see what happens. And that was what turned into the information integration work, which was the majority of what I did for many years at ISI. And in fact, the research that I do is still related to that. So it was luck and some of my doing, but it was certainly a very difficult time because I was faced with a situation where, either I make this change to what I've been doing or I don't have a job. Right now, I'm primarily in an administrative position, but I do spend about 20% to 30%, it varies, on research projects. And the research project that I'm still involved in now is related to an area that I started at ISI back in the 1990s. And that was what we refer to as information integration. So the idea is that a lot of information is stored in computers. There are databases of different kinds. The databases, or whatever form you store the data in, are often created by different people or different organizations and for different purposes, but they overlap in content. So, as a simple example, you may have a factory, and there are people working and workers working in the factory, and there are things that you manufacture. And early on, someone created a database for all the workers, an HR database, right, for all the workers and their salaries and how many vacation days they have and how many they've taken and so forth. And then someone else created a database for managing the shop floor, right? How many employees you need in different sections and who's in and who's out and who replaces whom and so forth. These may have been created independently, but it's useful to connect them, because if you know how much time people are working on the shop floor, then you know how much they have to get paid. And then you can go and get their salary and figure out, how much you have to deposit in their bank every week. So this is a very simple example. Many years ago, people realized that actually you want to be able to pull all this data together into one program or into one database. But it's tricky because people described individuals differently, right? Had different kinds of information about them, because what you need for, salary payment is very different than what you need for, scheduling jobs. You need to know their expertise and all kinds of things like that, whereas you don't need that in order to pay the salary. You just need to know how many hours they worked and, what their base pay is. And so combining databases that were created by different people and for different purposes became a big area. In the 1980s or so, people realized there's a lot of benefit from combining these things. It's not trivial to do. The main reason that it's hard is because you need to know what these objects are that you have data about in order to be able to combine them. So you need to know, what it means to be a person as far as the factory is concerned, right? They can have dependents, they have skills, right? They have a salary. That's what a person is. And often in databases, you didn't include that information because you didn't care that this was a person. There was just some salary, number attached to them. And so people realized that what you needed was to describe the semantics of the objects that the database was about, the meaning, right? What they did, what they could do, what they were for, and so forth. Now that's something that AI was always trying to represent, right? AI started out trying to represent, things and what they can do and how big they are and how they interact with each other and so forth. And so it was a natural to try to combine AI with database people in order to solve this problem of integrating data from different sources. I happened to be involved in this early on. In part, it was sort of an accident, but I received funding and created a group at ISI that grew because as people recognized that there was value in this and that the results were useful, more and more funding came into this area, and it grew to be a significant part of what ISI does. I mean, other people took over the work over the years, and including the person who's now our director, Craig Knobloch. It's still a significant area of what ISI does. This problem of recognizing that there are different sources that describe objects that overlap. There's something useful that can be done by combining this data from the different places is still true. AI indeed has gone through major changes over the years. I mean, even way before my time, and the beginnings of AI are around 1950, late 1940s, when people believed, in retrospect naively, that computers could just mimic human thought and just do whatever people do as far as thinking, deciding, and so forth. That turned out not to be true. Well, at least not true yet. And it's not clear that we're a lot closer to that. The original idea was that we can figure out how people think and then make computers do the same thing, and then they'll think like people do. And then they can do all the tasks that people can do. Well, it turned out that we don't understand well enough how people think. And we still don't, even now. And so over the years, there was a major shift, which happened about mid to late 1980s, during the my early years at ISI, to say, well, never mind how people think. Let's just develop some kind of algorithm that can perform tasks that we associate with people. It doesn't matter how they do it. Probably unlikely to be how people do it. But if it does it well enough, that's good. I mean, the analogy would be flight, right? I mean, you can see these old Leonardo da Vinci drawings of wings, right? You think, how do we fly? Well, birds fly, right? They flap their wings. We build a machine that has wings and flap them real fast, and we'll be able to fly. Well, that doesn't work for a variety of reasons, or at least hasn't yet. Instead, eventually people learned the dynamics of airflow and figure out another way to make heavier than air machines go through the air, and that's worked out very well. Not the way birds do it, but really, our goal wasn't to be birds. Our goal was to get people quickly through the air from one place to another, so it worked out great. Okay, let's do AI that way as well. And that's pretty much what people do today. So if, the way a car drives, it does not drive the way a person does. It doesn't reason about objects the way a person does. You collect a lot of data about, what things are out there and how, a driver would react to them. And then eventually you build that into your system, and it sort of, avoids obstacles, knows when to stop. Not the way a person does, but that's fine, because ultimately we just want to be able to sit in the car and have it drive for us, right? Doesn't have to do it our way. Despite all our work in AI and in psychology and anatomy, we still have not come close to being able to build an electronic model of the brain that functions the same way that the brain does. It would be great if we could, but we're not there yet. There are different aspects to this. There's, of course, the ability to do interesting work. So there's a lot more funding out there for this. And by the way, I mentioned, cars being driven, right, using AI. That's something that everyone knows, but that's not the only area where AI-ish work has been successful. I mean, think about Google and your ability to find, pretty much anything that anyone has ever written about a topic that interests you by just entering a few words, right? I mean, these things are things that everybody can use and everybody understands. And in fact, that is what makes it more, shall I say, fun or, nicer today, where, if I tell someone that I work in AI, they sort of know what I talk about, or at least they think they know what I'm talking about. I mean, because there are things in their life today that involve AI. And, it used to be, 30 years ago, or when I started this, where I tell people I do AI, I have to explain what it was that we actually do. And it sounded sometimes rather iffy. But today, you got ads on TV that talk about how some company is using AI in its products. I don't know if it is or isn't, but obviously the advertisers think that saying that will, make them sound better to customers. It turned out that things that we were hoping to do once are now getting done but they're getting done in a very different way, right? And your average person doesn't care if the plane they're in flaps its wings or uses jet engines as long as it takes them from, LA to New York in 5 hours. A person in a car that doesn't completely drive itself, but at least assists the driver in many ways, the person driving the car doesn't care if it's, thinking in any sense like a human thinks, or whether it's processing, the data in some way that is not human-like at all, as long as it helps them drive the car in a safer way and in a faster way. If you could make a car think better than a human thinks, or react faster than a human does, or pay attention more closely than a human does, that would be good, right? We'd rather it did that than do it exactly like a human. In some sense, that is already the case, right? A person can become tired while driving and stop paying attention, or even fall asleep, right? Your car's systems will not do that. Or they can fail, but they fail on a much, fail from, the battery running out or camera being damaged. They will fail, but much less frequently than a human can fail, right? So in that sense, it's better if they're not acting like humans. By the way, car driving isn't the first case where systems like this replace humans and do it potentially better. There are airplanes are flown by automatic pilots, and in fact, they're typically, better at landing planes than humans are because they can measure things more accurately. Well, the instruments can be shown to the human as well, but the automatic pilot can process things more quickly, isn't confused by fog as much, isn't distracted by things. So with cars, it's no different, and with systems in general, it's no different. I see no reason to believe that we won't have automated systems that can do tasks better than people, as we already have. But for thinking, seems to still be a ways off. In two environments, basically, during my life. One is, regular university academic department, whether as a student or faculty member, initially at USC, a regular faculty member, and at ISI, this sort of self-funded, what's called soft money research institute. The kind of work that I've done has been similar. Worked on similar problems. I find that the environment at ISI is much friendlier. And I mentioned this earlier when we were talking. The main reason is because people pretty much are responsible for their fate. They do not suffer in any way from the success of someone else. It sounds harsh, but in some academic departments, they're going to hire one new person next year, and if it's in your area, it's not in mine. And if it's in mine, it's not in yours, which sets up a potential conflict. And at ISI, that's not the case. People build their own future, basically. They can be happy with the success of others because it does not in any way impinge on them.